Course 3 Investigation 9. This will hopefully be a quick video on sampling methods that we're looking at in this investigation. So overall, we have different surveys that we want to do or information that we want to gather, and we need to be very careful about the sampling methods that we use in order to collect that information. So in this, we have some information to start with. So the U.S. Census Bureau reported that for a one-way trip to work, the average nationwide commute time was 24.3 minutes. The American Community Survey randomly selected households from across the nation to participate in a similar commute study. Individual state and city averages vary as follows. So we can see the nationwide here at 24.3, New York at 30.4, 16.5 for Nebraska, 33.2 for Chicago, and Tulsa 17.1. So we can see with this survey, a little bit different than the national average, but some above, some below, which makes sense as far as an average that's somewhere in between. So every 10 years, the Census Bureau conducts a study, and the intent of which is to survey every resident in the nation. This study, in which every member of the population is included, is called a census study, so everybody. So think about your school. If we were to collect information for every single student, that would be considered a census study since our population is the school. With a census study, it's possible to accurately describe characteristics of the population. If we know everybody's opinion, we can assume quite a bit about the population. So, a census of an entire population requires large amounts of time and money, so it's not very practical. It doesn't happen very often, and it's very difficult to do. Money, time, all of the volunteers or workers that you might need to do this. So instead, we would study a sample, a very small group of the population. So a sample would typically be considered representative if that sample is similar to the larger population, if it had the same type of ages or socioeconomic status or race or you name it. If it's representative of the population, we would consider it to be a good sample. If we collect a large enough sample randomly from the entire population, we can be reasonably sure that the sample is representative. Well, we would have to do this randomly, and our side panel here says a random sample is when every single member has an equal probability of being selected. So maybe if you had a group of students and your population was that classroom, well, everybody's name would be put on a piece of paper and put in the hat. Something like that, so that every single member has an equal opportunity of being chosen. So let's think about the test results that we had above. How might the results of the survey above differ if the sample was selected from only one city or state? Take a minute to write down your thoughts. Pause the video if you need to before I kind of go through my own thoughts. And then also, how representative would the results be for the entire nation? So go ahead and write something down for that. And when I think about this, well, if we only take a small population, even if it's collected randomly, if it's not representative of that original survey of the original population, it's not going to be representative of the entire nation. So if we take someone like a city like Nebraska or something, a city in Nebraska, or the entire state, and say, oh, the entire nation must be like this. We must all have a commute time of 16.5. Well, when we compare it to New York or Chicago, we would see that's not true at all. And even the cities in Nebraska don't even have as much commute time as just simply nationwide. So if we just pick a small sample that is not representative, then it's not going to be representative of the whole. It's going to be very low chance that it will be representative. So when we conduct a study, we randomly select a sample of sufficiently large size. When you talk about different statistical surveys, they do have numbers on this that have specific amounts that they need, but honestly, the bigger that you go with a population, the more that you really need in your study. So to do this, we might assign numbers to each member. You can probably think of ways that the U.S. has done this for their population, to have a number for each person, particularly like social security number. Or maybe in your school, you might have a number associated with you, like your student ID. For a while, things like a phone number would be a good representation of the household. But now that cell phones are a little bit more common, we might not use a phone book to actually choose people because some people don't have a landline anymore. Lots of people are not in the phone book. So it's not a very good way of choosing households. We would need a different way. So we're going to do this actually with a particular study to pick a random sample for this survey. So it says a health food store wants to test its consumers' responses to a new product. The researcher assigns a number to each person in the customer database and will use a random number generator to select a sample of students. So we're going to do this two ways. Number one, with a number table in order to say these are random numbers in a listing, and we are going to choose from there. And then second, we're going to use calculator in order to do this. Now I do want you to go ahead and answer this question right here with your own thoughts. So what population does the health food store want to survey? Why might the store want to survey this particular population? There are a ton of different answers for this. I'm not going to say them in this video, but think about why might a health food store want to survey its customers or the population in the community, whatever you think is the population that they are studying. So going ahead with the random numbers, let's say that these were our customers that we want to survey. And we go to a random number table, oftentimes found at the end of math books, or you can find them online nowadays. But here is our set of numbers. And since our people have two numbers associated with them, we need to split this number table into groups of two numbers. So in this case, 07, 81, 35, 12, 05, 94, 16, and 09. We have them all listed out down here. Okay? And then we look at our table and cross out any that aren't represented in our table. So 7 is a good one. We have that one right here. So we would pick this person for our survey. 81, we don't have a person associated with 81, so we'll cross it out. Same with 35. We do have a 12 though. That'll work. McNelly, we'll pick them for our survey. 5 works. 94, too big. 16 would work. We have that person. And 9 also works. So these would be our 5 people for the survey. If we didn't get 5 using this method, we would go on to the next section of the random numbers. But using this random number table, we would pick these 5 people for our study, ask them questions, hopefully they agree to help us out, and then go from there. But we also have another way to do that, and that's listed in your book as well in this section right here, but I'll also show you on a calculator how this is going to work. So the first thing that we need to do with our calculator is go to, basically this math section has a bunch of different things. The first tab right here isn't going to help us all that much, but we can tab over to the probability section, and we will see number 5, random integer, rand_int, and that's the one we want, number 5. And we need to set this up for our survey. So we want the lowest number possible for these people, that's 0. The highest number possible is 19. We can always change these if it's not that number. And then we need to say how many different people do we want for our survey. Well, we want 5, but even in a random number generator, we might have some repeats. So I'm going to pick 10 different random numbers and just take the first 5 unique ones. So we're going to go down, paste this, and it'll paste it into our calculator page. Once we press enter one more time, we will see these different numbers. So we get 15, 11, 6, 4, and 12. Those first 5 are all unique, so I'm going to go with those 5 people. And those would be the people in my study. Okay, so I would match them up to the table like before and call those people. Hopefully they will do the survey for me. Okay, now with that, we use random sampling. Other methods will also work for conducting a survey, something like systematic sampling, in which subjects are chosen from a list with equal spacing between selected subjects. Or maybe we have a line of people and we go down and choose every 5th person in the line, or every 10th person, or every 7th. We can kind of choose that random number using a random number generator, or however we need to. For example, if we did this with our customers and we chose every 4th customer, we would get 03, 07, 11, 15, and 19. regardless, if we do random sampling or systematic sampling, we're going to get some sampling error, just like you would in a science experiment. If we can minimize that error, that is the best for us. Error is minimized when we use objective methods to ensure an equal probability for any population member to be selected. In an actual study, we would select a much larger sample, okay? Much larger sample. So in a city like Denver, we would choose probably thousands of people for a study, or as many as we can get, since Denver is such a large place to live. We wouldn't want to just pick 5 people. That would most likely not be representative of the entire population. Even 20 people would be really small for a large city. So let's look at these 2 surveys and identify a problem. Once again, take a second to pause the video, read through these, and answer for yourself, and then continue with the video. So it says identify a problem with each sampling method and describe a better sampling method. So A says, Matthew wants to know the percentage of students at his middle school who favor school uniforms. He decides to ask everybody in his English class. Well, I see a problem with this. If he wants to actually know the information about his entire school, he should probably not just ask his English class. It's like going to our school, a K-8 school, and only asking the kindergartners a question. Something like, what do you like to do with your free time? Or what's your favorite thing to eat? Most likely, those kindergartners would not give a response that is representative of the entire population of a K through 8th grade school. It just wouldn't. So in this case, Matthew should probably pick a few people from every single class in his school if he wants to know their opinion on school uniforms. So maybe randomly select them, or maybe he does a systematic sampling method as kids enter the gym for the school day. Okay, and then the second one. In response to requests for a new softball diamond, the City Council would like to know how important building a softball diamond is to the residents. They asked researchers to conduct a phone survey by randomly selecting 20 names from the city's phone book. Well, there's a couple different problems, especially in this day and age. Number one, the most obvious one is 20 names is probably not going to be enough for a city. We would probably need a couple hundred, if not more, depending on the size of the city. So number one, he should change the amount of people that he is conducting this phone survey with. The second one is maybe there's a different way to reach out to people, because I know a lot of people that if they don't recognize a number on their phone, they're probably not going to pick it up. Or maybe they don't have their phone number in the phone book. So not every member is actually represented and given a chance to be part of the survey. So maybe they reach out through a text message or through an email, or maybe they go and actually go to grocery stores or libraries or you name it to talk to them face to face. As much as they can, they want to have a representative sample. Okay, and then last question for this investigation that we'll go through. Consider the following questions. And we need to figure out which one is the best one to actually ask that is the least biased. Meaning, we want the one that doesn't sway our population into answering the question how we want them to answer. Something that will leave it open that they can actually answer how they want to. Something that is not biased. Okay, so number one, wouldn't you like a new softball diamond at Philly Park? Number two, which of these describes your desire for a softball diamond at Philly Park? I don't want one, I feel indifferent, I would like one, or I want one built soon. And number three, the city pays for many services under a tight budget like street lighting, crossing guards in front of schools, park maintenance. How important is it to you that the city build a softball diamond at Philly Park? Make sure that you pause the video and try this out for yourself and decide which one you think is the least biased, and then come back. Well, when I look at these 3 questions, I see an issue with number one. Wouldn't you like a new softball diamond? Well, that kind of puts an idea in their head. Wouldn't you like one? Well, when you put it that way, sure I would. You're leading them towards an answer. I also see an issue for number 3. It's almost like making them feel guilty for saying yes to this when so many other things need public funds. Things like making sure the roads are kept up, or new construction, or crossing guards. So it kind of leads you to say, well, yeah, those are important. No, I don't think that a softball diamond is actually that necessary. The second one, in my opinion, is definitely the least biased. It gives people a range of options, but it also allows them to not feel like we're persuading them into one particular answer or another. We need to make sure that our questions are similar to number 2, even though they're not going to all be perfect, but we want to make sure that our survey questions are not biased. Okay, now a good way to do something like this is to actually practice for yourself. If you would like, of course, go ahead and conduct a survey, maybe even just with your family members or something like that. That would be fun. But make sure that you're randomly sampling or doing systematic sampling. Make sure that everybody has an opportunity to actually respond, and also make sure that the question that you're asking is not going to be biased. All right, well, I hope this helps with your homework and for studying.